Hi there. My name is Fermin Castro. I'm part of the Maximum Availability Architecture team. And today I'm going to provide a quick overview of the WebLogic Hybrid Disaster Recovery Framework. This is a framework that will allow you to create a secondary system for a primary, where the secondary will be hosted in Oracle's cloud infrastructure. Typically, the primary system could be on premises, but it could be also another OCI system. It could be even a different cloud and different types of flavors. Again, the main aspect is that the target, the secondary system that will provide protection against disasters, will run in OCI. The main benefits of the framework is that it provides an entry point to Oracle's cloud, meaning that it allows you to provide protection against disasters, but at the same time, it lets you test and verify that production workload in a secondary system. As you know, disaster protection for most WebLogic and Fusion middleware systems is active-passive, meaning that the secondary side remains passive from the point of view of processing the primary workload and the production workload. But that doesn't mean that you cannot test and verify things in that secondary system. And this is one of the key aspects of the hybrid DRC topology, which is that it will allow you to open the secondary to verify patches, to test new versions of your application and things like that. And while you're doing that, you get familiar with Oracle cloud infrastructure. It allows you to verify how storage works, how network works, how load balancers works, and so on. At the same time, by using this solution, you're leveraging all the high availability capabilities in Oracle cloud infrastructure. We provide redundancy for compute instances at the fault domain level, availability domain level, but we also provide redundancy for components such as the load balancer, the storage, and all that is inherited. All that is provided out of the box for the cloud infrastructure, and you don't need to implement it yourself. It's a feature, it's a number of features and capabilities that you get for free. And finally, another great benefit of these type of solutions is that they allow you to reduce the total cost of ownership of your disaster protection system, but not only by means of the licenses that you need to pay for, the infrastructure that you need to pay for, and the like. It's more than that. We are talking here about reducing the total cost of ownership by minimizing the amount of administration work that you need to do to manage that secondary site. When you use a hybrid solution like this, you get a ton of infrastructure that is automatically managed for you. The storage is set up and managed for you. Load balancers are set up and managed for you. The network is set up and managed for you. In typical and traditional disaster recovery solutions, you will have to set up an entire second data center, administrate this network, its storage, and all that. All that reduces the cost of the solution tremendously when it's OCI, what we use as secondary. Besides that, by using universal credits, the hybrid DR solution allows you to test for some time a disaster topology, verify if you're happy with it, make sure that you understand its implications. And if you're not happy with it, you can just clean it out, completely remove the resources, and get back your universal credits and use them for other purposes. So it's a very low risk type of deployment with many benefits, both at the cost level and also from the high availability and, of course, disaster protection level. The topology that provides this disaster protection is as follows. It's key to every DR solution that the secondary system is a mirror of primary. In the topology that we set up with the WebLogic Hybrid DR framework, you have a primary where you have redundancy at the web tier level, redundancy in the app tier level, and then we set up a secondary, okay, with exactly the same components in its tier. We provision the web tier in the same way, the tier in the same way, and we also create a storage for you, subnets for you, and a number of components that will be using Oracle's cloud infrastructure. The communication between your primary and your secondary happens through a fast connect link or a virtual private network. That is key to the setup and to the ongoing replication between primary and standby. Is through that fast connect link or through that VPN connection, that we will be replicating the database from primary to secondary using Oracle Data Guard. And that will be replicating configuration changes, runtime artifacts, binaries, and everything by rsync. And rsync has a star by the name because we are using an advanced rsync framework where we validate and do a number of operations to make sure that the rsync copies are really, really reliable and well validated. The key aspect to the whole DR, to most DR solutions is that actually you are replicating on an ongoing basis from primary to the standby. And there is a process that involves a database that it's managed separately by the other frameworks that we provide. But there is a library set of things that you need to do to create that secondary topology, right? As a copy of primary. Well, automating those tasks is very important because it avoids mistakes, which happen very frequently in the setup. It provides a reliable and repeatable process that you can re-execute, clean, execute again to verify that you get what you need in one region, or if you decide to move to another region, and you get that exact mirror in a very precise and repeatable way. And it also implements security per the Oracle recommended best practices and is compliant with what we provide as MAA recommendations for disaster protection. By using this framework and this approach to the R, you are getting for free many high availability features and many MAA recommendations that we will implement for you when you use our framework. One of the key aspects is that the framework is intended to be used in the context of maximum availability for an ongoing replication and a continuous copy from primary to secondary, because we do not recommend to create that secondary when the switchover event takes place. It's a very risky approach to disaster protection to create all the resources in secondary when a disaster happens. We don't recommend these sort of solutions because we have experience with them, and it's really risky to create all the resources, to test everything for the first time when a failover happens. And in summary, we recommend to using this pre-paired switchover approach in mind, and have everything ready. Furthermore, one of the MAA recommendations is to test your secondary on an ongoing basis to verify that everything that you have in primary is well replicated to secondary, and that secondary site works and behaves as you expect it to behave, so that when you need a real failover, the number of operations and the number of verifications that you need to run is minimized, and the switchover can happen as quickly as possible. A key thing of the framework as well is that actually the framework is an open source. This means that you can grab it, extend it, customize it, or add modules to it, or modify it to adjust to different requirements that you may have. It's available in GitHub. You can download it from it. And it has been created based on a number of white papers that we had in the past, where we had like 50 pages of the steps that you will need to run to set up a secondary hybrid DR environment for a primary. Okay, we have measured these in a very detailed fashion, and we have come down to numbers like these. We have reduced around 40 tasks to just around 3 tasks that you need to run, and the whole process of setting up and having your system ready in secondary has been reduced from around 9 hours to just 1 hour. In this process, we're not considering the database, because the database, obviously, if you have a 30 terabytes database, the amount of time that it will take to copy that database is the biggest chunk of time and operations, right? So those numbers that you have, 39 tasks to 3 tasks and 9 hours to not 1 hour, are steps not considering the database setup per se. Okay. Now, what the framework does for you? What are the main things that the framework does? Well, as I said, it creates and configures a symmetric secondary for you based on the primary. It connects to primary, it discovers it, and it will create a secondary for it, replicating everything as you have it in that primary. And this is one of the key aspects of the framework as well. We do not use a model where we create a secondary WebLogic domain and redeploy ER files, data sources, and JMS servers to it. No, we copy everything as you have it in the file system in primary to that secondary system, which improves not only the RTO and the RPO, but the management operations on the system. Now, it's also important that you understand what the framework does not provide for you. The framework does not take care of setting up the connectivity between your primary and your secondary. If you're in OCI, it's pretty straightforward. You can just create a dynamic routing gateway. You will have connectivity between two regions. If it's an on-prem system, we will not set up fast connect for you. Those operations need to be done separately. And besides this, the framework doesn't take care of the database tier as well either, meaning that if your WebLogic domain is using a database, as is usually the case, you will have to set the secondary database separately from this process. For that part of the process, we provide you with additional scripts. If you want to set up the secondary database with continuous connectivity between primary and standby, we provide you scripts to set up data guard. If you want to create a secondary database as an export-import copy of your primary, we also provide you some scripts that you have available there that will use Oracle Data Pump to export and import your database as you have it in primary, okay? In terms of features, well, the framework is intended to be reliable in terms of creating that mirror copy of your primary. So it produces that secondary in a consistent and repeatable process. And since it's based on a full copy of your primary, it's going to propagate all the patches and all the one-offs and all the config as you had it in primary. So it's not, again, this is a key aspect because it's not like we are creating a stack based on precise binaries in secondary that could differ from whatever you have in your primary and production system. No, we're going to replicate exactly your production system as it is. It's intelligent because it has some standard logic to retry when there are conflicts in resources. It allows you to reduce subnets, and it has multiple conflict checks that will allow you to behave properly if there is an existing file storage that is already in conflict with the one that you are trying to create again, and all that, okay? Furthermore, the framework is pretty intelligent in determining what you're running in primary. We'll create the secondary system based on an introspection of that primary, and we'll detect things like what is the memory and CPU that your primary nodes are using, what is the OS flavor that your primary is using, and based on that, we'll create the OCI resources during the creation phase of the framework. As another and probably the key aspect of everything of the features that included in the framework, we virtualize your primary system for you. This is what we mean by virtualize? Well, we are basically taking your primary WebLogic domain and configuration, we're shipping it over to secondary, and we're making that configuration that you have in primary work as it is in secondary. You don't need to manipulate it. You don't need to replace listen address and stuff like that, because we're using DNS private views that the framework will create for you so that the hostname listen addresses that you use in your production system will be valid in secondary. What this gives you is the automatic, validity of all your scripts and all your operations in primary, because you can run the exact same scripts to start manager, to start WebLogic administration server, to start managed servers in secondary as they are in primary, because those listen addresses, those scripts that contain ports and connections as they were happening in the primary region are valid as well in the secondary by means of these DNS private views that we create for you. And of course, the creation of the secondary happens following our best practices in terms of tier architecture. We'll create resources in different subnets with separation, with just the required ports open between the subnets, and with security and network connectivity as recommended in our enterprise deployment guide recommendations, okay? What are the main aspects of the internal structure of the framework? Well, the framework is in reality 3 different models. And this is important because one of the main, of course, the main objective of the framework is to provide the setup for a secondary system, but there are different pieces of the framework that can be used separately. So some of them can be used for other purposes or individually. The model provides 3 different, the framework provides 3 different models that each one, so that each one can be run separately and each one provides different features and operations. There's one model that takes care of discovery. This model is in charge of introspecting primary, finding what are the ports, what is the configuration for WebLogic that you're using, what are the the shapes and everything that needs to be that is detected in primary. There is another model that is scared of replicating stuff. It's the model that will allow you to copy things from primary to the Bastion host and from the Bastion host to the OCI compute instance that will create. And then finally, there is a model that is they scared of provisioning that will run the execution of OCI APIs to create file storage, log volume, load balancers, and all that automatically for you. All of those are separate, but at the same time, when they run together, they basically allow you to automate all these setup process. What we do, as I said, is with the three models is connect to a primary system, introspect information in that primary system. We ask the user for additional choices. Hey, we have detected that you're using these three different virtual hosts in our chassis. Which one do you want to use for this precise application or domain that you're migrating or setting up the R for? And after you provide those choices and you feed the choices that you want to make to the framework, we'll create the secondary system with everything that you have in light green in your screen on the right. And we'll replicate your binaries and config as they are so that you have that exact mirror that we recommend using for disaster protection purposes. With that explanation, the next thing is to understand how you can use the framework. The main use, of course, is what we call the complete DR setup, which is that you have an ongoing connectivity between your primary and your secondary through Fast Connect or through a virtual private network, okay? And you have data guard for the database, continuously replicating database to secondary and continuously or on a regular basis, syncing your primary configuration from primary to secondary. This is the MAA gold type of approach because it provides the best RTO, the best RPO, and again, it requires obviously that the two locations, the primary and secondary, are connected with a secure, individual, and reliable piece of network that will guarantee all those reliability aspects that we have mentioned. The other approach, however, that you can use is what we call the backup and restore to OCI. In these type of solutions, instead of having continuous connectivity, you just take a backup of your primary system once in a while and ship it over to the Bastion host. You run the framework in the Bastion host, the Bastion framework will introspect that information that you have placed in the file system in the Bastion and will create the resources and replicate the WebLogic domains and the WebLogic Oracle homes and OHS Oracle homes as you have it in that copy. Obviously, the RPO of this solution is worse because the RPO depends on how frequently you're taking backups and shipping it over to the Bastion host. But at the same time, it's a valid approach that allows you to test quickly your production workload in secondary. And although it has a lower RPO, you can optimize it to provide a test and validation copy in OCI that allows you to verify, again, all your production system in OCI resources. On top of that, there are other use cases. As I said, since we provide this modular framework, you can use its different pieces for different aspects. One of them is analyzing just the topology that you have in primary. Another one is just replicating using the replication model to copy whatever you feel like from the primary location to OCI. And of course, there is just one part that allows you to create just compute infrastructure and the storage infrastructure and load balance infrastructure. You can use the framework to create the OCI components that we typically use in an enterprise deployment guide in OCI automatically. This means that we will not set up WebLogic and OHS configuration, but we'll create the compute instances that you need, the load balancer that you need, the network ensembles that you need, all for you automatically, okay? Different usage based on the different models that we provide you with. So let's run now a quick demo of the framework. More than a demo, this is a walkthrough because the demo in reality, if we consider a typical domain like WebLogic, like Fusion Middleware SOA, that's around 40 gigabytes. And I don't want to spend 1 hour just copying binaries and config from a primary. So instead of that, I'll just provide a walkthrough through the main steps. If you need or want to see a full end-to-end recording with all the details of the setup running through every single step in detail, you have a link to the video there. You can use that link. And there you have, again, it's a very detailed demonstration with all the little things that are happening under the covers when we run the process and the setup, okay? In this case, we're using what we call the orchestrator script, which is a script that runs on top of the different models that I mentioned in the beginning that will automate the whole thing for you. You just configure a few things, run the orchestrator script, and you will have with that a secondary system created. So what are the main steps? Well, first you need to prepare the Bastion node. The Bastion node is required because that will be the orchestrator that will be connecting to primary, creating resources, introspecting information. It doesn't need to be a big node, but it just needs to have enough storage to host the copy from primary. Once that you have the Bastion, you download the framework from GitHub, the WebLogic HA framework, and you configure it with a few files. What are the main files? Well, you need to tell the framework where your primary resides, what are the IPs of your nodes, and what are the OS users and groups that you're going to use in your primary system. And then you also need to tell it, okay, these are the precise WebLogic domains that I want to, the WebLogic domain that I want to replicate. And this is the Oracle homes that will be that I want to take care of by the framework. You provide this in another configuration file that is intended for just the replication phase, where you tell okay, these are the paths where I have my Oracle home in primary. This is the path where my WebLogic domain resides in primary. And on top of that, we allow you to customize additional things. We provide you with a spreadsheet type of configuration file where you can enter things like the compute instances hostname prefixes, the number of the subnets that you want to use, the mount point target names that you want to use, and many other things that you can customize in an advanced fashion to extend the framework. Okay, once that you have configured those files, you just run the WLS full setup script. Again, this is the orchestrator script that will do all the operations for you. Now, at the beginning, it will just connect to your primary system. It will introspect it and see the domains, and will start pulling information from those different hosts to the Bastion node. We'll copy Oracle homes and we'll apply domains or hsconfig, and we'll bring in everything to the Oracle home. This is the part of the process that typically takes the most because it's obviously, it involves replicating multiple Oracle homes, okay? But once it's completed, the framework will introspect that configuration that it pulled from primary. It will say, oh, okay, these are the ports that you're using. These are the Oracle homes that we need to take care of. This is where your installation resides. These are the host names that you have in your WebLogic nodes, and a bunch of additional configuration. We give you the option to select different things. Like, again, if OHS is using multiple virtual hosts, we'll let you, okay, which one of these do you want us to use for your apps? Is this the one that you want to use, or which one it is? Because you may have an OHS front-end in multiple domains, and this framework migrates just one domain at a time. So once that you have all those selections and options marked, the next step is actually creating resources, and the framework will start creating, the subnets, the file storage, the block volumes, the security rules for the different subnets, and all that explosion of a full-blown multi-tier architecture will be created for you. Once that's completed, it will just copy the binaries and config from the Bastion to the OCI compute instances that were created, excuse me, and you will be ready to go. At the end of the process, you will end up with something like this. Again, all the things that are highlighted in light green will be created for you. And each one of those hosts will have the Oracle homes and the config replicated from your primary system, okay? After that, you just need to validate your system. And this is the key thing that I wanted to highlight, which is that to validate, you can run precisely the same scripts that you had in primary, execute them as they are in secondary. Why? Because of that virtualization aspect that we mentioned, where we are creating DNS private views to make the host names that are used in primary valid for the IPs that we use in secondary. As you can see here, we're connecting to Node Manager with the same scripts that we had in primary, and we can run the same pipelines, the same deployment scripts that you may have to deploy WARs or ER files. They should just run exactly the same with no issues at all in the secondary system. With that, if you want to perform a full switchover operation, the only remaining thing is to remap your front-end addresses to the IP of the load balancer that we have created in secondary. In this case, we are showing the example of mapping the front-end address for the admin console to the IP of the load balancer in secondary. And with that, you should be able to access your admin console and see the number of servers and everything that you have in your WebLogic domain in secondary. And in this case, as you can see, it's a complex domain. It's SOA with a cluster for SB, a cluster for SOA, and a cluster for Web Services Manager. And again, in this precise walkthrough, This whole process took me around 55 minutes. And that's it. You are all ready to go. And this is pretty much a brief description of the different steps involved in the setup. Once more, if you want to verify the full-blown setup end-to-end with all the different small details, refer to the link to the video that I provided at the beginning of the demo section. And there you can run and stop everything as you wish so that you can understand in more detail each one of the different things that we do in the framework. And that's it. Thank you for your time. If you have additional questions, feel free to send an email to fermin.castro@oracle.com and irache.echeverria@oracle.com, and we'll be glad to help you with the framework. Thank you, and I hope that you have enjoyed the session.